Hi, welcome to this lesson on Euclidean geometry, similarity and congruency. Let's have a look at congruency and polygons. So we'll start off with the definition. So we say that two polygons P and Q are congruent to each other, denoted by P with three horizontal lines, just like similarity had three vertical lines. Congruency is three horizontal lines. If and only if all the following conditions are satisfied. Okay, so just like we had with similarity, we still have the stipulation that condition 1 is that all corresponding angles are equal. So the order in which we write them, angle A1 is equal to angle B1, angle A2 is equal to angle B2, all the way up to the last angles. But now, instead of the corresponding sides being in proportion to each other, as in similarity, with congruency, condition 2 stipulates now that all corresponding sides are equal in length. So that means that if you look at the side A1, A2, it must be equal to the side length B1, B2. If you looked at A2, A3, it must be equal to B2, B3, all the way up to the last angle, last sides. So mathematically, this tells us that two polygons in the plane are congruent if and only if they are equiangular for all corresponding vertices, and the corresponding sides of each shape are equal instead of in proportion. So that's the key difference between congruency and similarity. So let's have a look at this example. If we have these two irregular pentagons, right, so five-sided shapes where not all the sides and angles are the same, we can check if they are congruent by matching up vertices that would be equal in angles and also side lengths that are equal. So we can see here that angle A is equal to, which angle here? Angle P. Then angle B here is equal to angle Q. Angle C is equal to angle R. Angle D is equal to angle S. And angle E is equal to angle T. So essentially we've got A, B, C, D, E, and P, Q, R, S, T. All those angles match up. So far we've only checked condition 1. But to check condition 2 for congruency, we need to check that in this exact order here, the corresponding sides are equal in length. So if I look at AB and PQ, AB is 2 units and PQ is also 2 units, so that's fine. Then I look at BC and QR. BC is 3 units and QR is also 3 units. So with congruency, just like with similarity, you need to check each corresponding pair of sides all the way up until the end. And in this case, for congruency, we need to check that the side lengths are equal. And in this case, each corresponding side lengths are equal. So this tells us that the two polygons are congruent, and we write it as ABCDE is congruent, okay, 3 horizontal lines, to PQRST. And again, we need to write it in this precise order, as this notation shows us which angles are equal and which sides are equal. Okay, so we can see that the red irregular pentagon is essentially a rotated version of the blue pentagon. All right, so if you just rotated this a bit, you would get the same shape. So essentially, with congruency, they are absolutely identical polygons in the plane. They just might be looking at different orientations, the way you look at them. All right, but they're exactly the same shape. So if you had to cut these two shapes out on a piece of paper and you put them perfectly over each other, they should match perfectly. Okay, so that's the whole idea of congruency. All right, so that's congruency and polygons. I'll see you in the next one.